solving the problem we need two theorems. One is lower bound theorem and upper bound theorem. By this we can calculate the plastic moment or the plastic load for a structure. The last classes we have discussed what do you mean by plastic moment and when a structure will go to plastic state, what are the states of a structure. So everything we have discussed. Now we will be looking into one or two formulas, and by this formula we can look into different cases how to get the plastic moment and take it further. See, we can find plastic moment or plastic load. So this is known as theorem of plastic collapse. So you can find MP. MP is known as plastic moment, and you can find that by using first theorem called lower bound theorem. This is similar to finding the bending moment and shear force by using different techniques, moment distribution, slope deflection and matrix flexibility. Like that you have two theorems here to find the collapse load. So the first theorem, it states that the moment are nowhere greater than plastic moment, is lesser than or equal to the collapse load. So this is the understanding here, and for upper bound theorem it is considered as greater than the moment and it is a kinematic method. So for all the shapes it is well defined, and just you are going to understand those concepts. The key word here is the moments are nowhere greater than plastic moment. If you find the plastic moment, this lower bound theorem states that the moments are nowhere greater than the plastic moment, is lesser than or equal to the correct collapse load. How will you find the collapse load is, you will take the system as under equilibrium condition, and by considering the equilibrium condition the moments are nowhere greater than the plastic moment. This is what stated by lower bound theorem, and this is the upper bound theorem. You can see the difference. There it is static method. See, this is static, and here you can see this is kinematic or upper bound theorem. Always state that load computed on the basis of an assumed mechanism always greater than or best equal to the correct collapse load. In the previous slide, so what was the statement? The moments are always nowhere greater than the plastic moment. Nowhere is written here and the letter nowhere is not here. It is always assumed as greater than. If the moment or the load is assumed as it is greater than, best or equal to the correct collapse load, then it is known as upper bound theorem. And this kinematic method, this also is derived and identified by Wurtzer, Greenberg and Prager. Let us go to a problem. Determine the shape factor for a rectangular beam of width B and depth D. So this is shape factor is similar to moment of inertia. Shape factor depends on the shape of the section, whatever you are using. See, in your civil engineering members, whatever members you are designing, it has some cross section. If you are cutting this beam, you have a cross section of a rectangle, and if you are cutting a column, the column can be a rectangle or it can be a square, or in certain cases you have circular column also. In ancient structures, many of the column are found it has a circular structure only, not a square or rectangle. So you can find the cross section like that. So for all the shapes you have a advantage and disadvantage. So when you are constructing the same column by a circular shape, has some different behavior, and when you construct a column by rectangle shape, it has some different behavior. Sir, what is the difference in that? I am giving the same reinforcement, that is 8 mm diabar at totally you can take it 6 number of 8 mm diabar as the column reinforcement. If you provide for the shape of rectangle and you test with a column which is having the shape of a square or the circle, you can make small models, and if you test that, shape plays an important role. The same material, the same concrete you can put, but if you change the shape, what happens? The moment of inertia changes. So in certain area it can take more load, on certain area it will take lesser load. What happens if you have a rectangular column? if you have smaller width at this direction and larger width at another axis, what happens? You cannot try to push in the direction which is having higher depth. So if you are trying to collapse, what happens? If you are having more depth behind that, the structure will not collapse. So if you have smaller depth, if you are pushing towards the axis, what happens? It will collapse immediately. So the circular column has the moment of inertia at both y and x axis the same. Yes or no? What is the formula for Ixx for a circular section? Pi d power 4 divided by 64. That is the formula. This formula is same for Ixx, also for Iyy. But in case of a rectangular section, what is the formula for finding moment of inertia? Bd cube by 12. If you want to find Iyy, db cube by 12. Yes or no? So you have different formula. So you will be getting different answer. Whichever answer is greater at that axis, you will be having more resistance. So you can find by that. Before understanding to the collapse, you should know shapes. Which shape is very much better? You can try the beam with a circular beam. Instead of casting a rectangular beam here, you cast a circular beam and you can lay it here. You can lay the same way. You can do it and you can proceed. But why they are not going for circular beam? Do you have any idea, or have you thought that why we always want to go for a rectangular beam? Why can't we go for a triangular beam or for circular beam? Is anybody have stated any law that beam should be rectangular? Is any law there? Is any statement is given in code book? No. But why all are using the rectangular section? You have certain backup, no? So this you are going to understand in this shape factor concept. Shape factor equal to mp by my equal to zp by ze. So this is the formula. You can take this as the formula. How to find zp? I have given the formula. How to find zp? Zp equal to a by 2 y1 bar plus y2 bar. What is y1 bar and y2 bar? If you are having any section, you can cut that into two half. What is that? Equivalent area. You can cut into equal area and you can cut that. Then you will be getting half of the section at top, the another mirror at the bottom. So what is y bar? The centroid between this axis to the G of the shape, and Z, this is the ZZ axis from this reference point to the centroid will be taken as y2 bar. So if you find these two and area, you can find ZP. First draw the rectangular shape, cut this into two half. How you can cut? If you have the total depth of D, so where you can cut exactly? D by 2. If you are cutting at exactly D by 2, you will get two shapes. Okay. How to find the centroid of the first shape? Definitely if this is D by 2, then it will be locating at half of D by 2. What is half of D by 2? D by 4. So you will get y1 bar and y2 bar. You will be getting both the answers. Okay. Now you can find ZP. How to find A is known as area. How to find area of a rectangle? B into D. That's all. Okay. Now the another factor is ZE. What do you mean by ZE is elastic section modulus. What do you mean by ZP? Plastic section modulus. So elastic section modulus you can find it by, what is the formula for Z? Formula for section modulus. I by Y. What is I? Moment of inertia. What is the formula for I? For a rectangle. BD cube divided by 12. So this is what it written here. I equal to BD cube. Instead of D, we have considered as H. The same thing, BD cube divided by 12 divided by, so what is Y? That is neutral axis. What is the depth of neutral axis? D by 2 is the depth. So you can substitute D by 2. What is ZE? ZE equal to this 2 and 12 get cancelled. You will get 6. D cube and D will get cancelled. You will be getting BD square by 6. So ZE is BD square divided by 6. A is B d by 2, y1 bar is d by 4 plus d by 4. If you simplify, you will be getting bd square by 4. Now you can find S or V. What is V shape factor? What is the answer? If you divide ZP by ZE, you will be getting the answer. BD square by 4 divided by BD square by 6. You will be getting 1.5 as the answer. So you have shape factor for a rectangle is 1.5. Now what is your understanding here is, if you try to push the object, this is an object, this is a rectangle object, if you try to push in this direction, it will be having, say for example, 10 kilonewton of resistance, and if you try to push in this direction, what will be the resistance? It will be 15 kilonewton. By using the shape factor, shape factor easily identifies that what is the resistance availability for a shape. If you find shape factor as 1.5, then you can understand that at this axis, so what is this axis? IXX. At this axis you have more resistance towards bending. If you have for certain shape the answer as 0.8 or 0.9, for certain shape you are getting 1.2. Which shape you will go for your structure? Either for 0.8 or 1.2. For 1.2 shape factor only you have to construct your building. If you are constructing for 0.8, what will happen? It takes lesser the load than the 1.2. The collapse will occur much earlier. So this is what the advantage of finding shape factor. So you try with different shapes. Try with a trapezoidal shape. So you try with a beam which is having a trapezoidal shape like this, and you can find the shape factor. If you find that, you will be knowing that why we can't use circular shape, why we can't use triangle, like that. Keep on, you can open your imagination. This is what it has been done by 1979. They have tried before how many years? 50 years. Determine the plastic moment capacity and shape factor. These two components has to be identified. An I section is given. So this is Indian standard mild beam section which is having a 400 mm depth. So this is the section which is given. For this section, what is the shape factor and the plastic moment capacity? With the root radius omitted, assume Fy equal to 250 MPa. Okay. So first let us find the shape factor. In order to find that, so you should know this formula. So V is known as the shape factor, Zp by Ze. When finding the plastic section modulus and elastic section modulus. Okay, let us first find the plastic section modulus. You know that the formula is A by 2 y1 bar plus y2 bar. This is the formula. And what do you mean by Zp is, this is a section, when you cut it, the half in the compression zone and the half in the tension zone will be equal. So this is the concept behind that. So we can easily find y bar. So what do you mean by y bar is, from the equal area axis. This is known as, there are two axes which you should know to differentiate. One is neutral axis and another one is equal area axis. When finding the plastic modulus, you are dividing the section by equal area axis. When your section is symmetry in both y-axis and x-axis, you will be getting equal area axis and the neutral axis. Both will be same. In certain problems, if you have unsymmetrical sections where you will be getting neutral axis at different distance and equal area axis at different distance. So when solving the problem and understanding, you will be knowing that. So this is just a note. Okay, so when I am dividing this section into half, so I will be getting a T section. So this is that half of the section. You have to find the y bar. So how to find the y bar, which is, if I am taking this as y1 bar, I am taking this as y1 bar and finding the centroid of the T section. Okay, how to find the centroid? You know the formula, that is a1 x1 sorry a1 y1 plus a2 y2 divided by a1 plus a2. Okay, what is a1 and a2 is, I have taken this as a2 and this as a1. So when you are taking the rectangle, first rectangle, so what is the size in breadth, which is 140, and depth you have it as 16. So this is the same depth. So when finding the area, you will be getting 140 into 16. Okay. Then the second area will be, if this is 200 mm, you know that if you are cutting the section into two half, you will be getting 200 mm, and the total distance is 200 mm. If you subtract the thickness of the flange, 200 minus 60 will be 184. So you have 184 here. So this is the second rectangle. So 184 is the depth, and breadth will be, it is given as 8.9. So 184 into 8.9 is written here. Okay. Then what is this 192 and 92 is? This is the distance from the equal area axis to the individual centroid. So where will be the centroid for the first section? So it is having a depth of 16 mm. So you will be having at 8 mm. The centroid will be for a rectangle at half of the depth. So you have a depth of 16 mm, the half of the depth will be 8 mm. From the axis, if you want to calculate, so what is this total distance? This is 184 plus the 8 mm. 184 plus 8 mm is 192. So you will be getting the first centroid as y2. Okay. Now the second area. For this area, how to find the centroid? You know the depth as 184. So half of 184 is 92. So you got the centroid at 92. So this is y1 and y2. What is the formula? a1 y1 plus a2 y2 divided by a1 plus a2. So you will be getting this answer. Now you tell me what is y1 bar. 149.76. So this is your y bar. So what do you mean by y bar here? Which is the centroid of this section. Even though this section is having 200 mm depth, where you will be having the centroid? From the equal area axis up to a height of 149.7. So at this distance you will be having the centroid. y1 bar you have found out. Now you find y2 bar. How to find y2 bar? y2 bar is the next distance from the equal area axis. The top centroid distance is y1 bar, the bottom centroid distance is y2 bar. So here you have found that the centroid is acting here and the distance is 149.76. Okay. Now you find the same way where you will be having the y2 bar from the equal area axis. Since due to symmetry, what do you mean by symmetry? If I am cutting this, the top half is similar to the bottom half. You have same 200 mm, the width of the flange is also 140, thickness is also 16. So all the parameters are same. So you will be getting the same answer. Hence y2 bar will be 149.7. Okay. If you know y1 bar and y2 bar, so what is A? Which is the area, you have to find A by 2. So the total area, you have to find the total area and divide it by 2. You have two flanges. What is the size of the flange? 140 into 16 into 2. You can multiply by 2. Why? You have two flanges like this. So you can do it 140 into 16 into 2. Then you have the web of the section. This is web. And what is the depth of the web? Since this is 16 mm, which will be the depth which has to be omitted, and here you have 60 mm. So 400 minus 16 into 2, 368. Okay. So 368, and what is the thickness? 8.9. So 368 into 8.9 is how much? 3877. So as per the formula, you have substituted everything, and currently you will be getting ZP. So what is the value of ZP? 1.161 into 10 power 6. So section modulus unit is mm power cube. So mm power cube is the unit for section modulus. What is the unit for moment of inertia? Mm power 4, and find the difference. For finding the section modulus, the unit will be mm power cube. You can also find by using this dimensional analysis. What do you mean by dimensional analysis? Is what is the dimension for area? What is the unit for area? Mm square. What is the unit of this distance? Y is distance, no? So what is the unit of distance? Mm. If you multiply mm square and mm, what you will get? Mm cube. So when you are not able to find certain dimensions, you can find the individual dimension and multiply, you will be getting the same answer. So this is another technique of finding the things. Okay. Now what do you need? First you have found out ZP, now you need ZE. So how to find ZE? What is the formula? I by Y, isn't it? What do you mean by I? Moment of inertia. What do you mean by Y? Depth of neutral axis. See students, I can see many of the students are not concentrating. See, as a professionalist, you should be able to increase your concentration power. See, concentration is a very important virtue which everybody will having the variations. Each and individual in this world have the variation of concentration. A small kid, if he or she is having or studying LKG, she can only concentrate for 1 second or 2 seconds. So you call him or her and you teach him that ABCD letters. They will have concentration for 5 seconds or 10 seconds. If you start saying A, B, C, they will slightly turn here or there, they will look down. Or so what is the difference is, the small kids will having less amount of concentration. When you are growing, what is the parameter identifies that you have grown or not is the concentration level. See how much of level of concentration if you get is the level of your maturity or the level of your improvement. As a human, you have to develop that. See, certain beings or certain living beings cannot concentrate. What is the difference is how much you can concentrate, which will be the level of elevation in your life. Level of elevation. The elevation might be in whatever career you are. Try to improve that character. This is an inbuilt character. Everybody can build that. It is not a big deal. Everybody can build the concentration. And you need training for that. Simply it will not come. Concentration power, or if you want, you know that you need education, but you cannot do that. Why? Because distraction of concentration is lot more. Distraction due to mobile phones, distraction due to friends, distraction due to all entertainment around us will be having. Everybody have that same distraction. Whatever phone you are having, same the teachers also have. Whatever the entertainment facility you have, same the teacher is also having. What is the difference is, you should know when to do what. That is the level of maturity. The kids are not aware of doing that, but as an adult, in this stage you have to know that. How a person can be extraordinary and ordinary depends on same parameter. If you are keep on looking that, everything will be same. But one thing is, a kid, you can teach a kid that a quote, Vande Mataram. You can teach the kid a simple slogan. The kid come there at the stage and say that Vande Mataram. Only a simple letter. Not knowing the level or in depth of the words understanding. But if you are fighting in your borders and if you have conquered 1 feet of the enemy, at that point you are saying Vande Mataram. Is it the same? Is it the same? No. The difference between understanding and the level is, the kid can say the word, but they have not taken the word to the meaning. But a soldier will be doing the job with the meaning. That is the difference. Understand the difference between a kid and a person who is matured. Right now you are growing as matured, so know this character. So this character will make you a better person. This character will make you a simple engineer to extraordinary engineer. Software is a skill. Getting a martial arts is a skill. On a single day you cannot get it. On a single day you cannot swim. On a single day you cannot become a bodybuilder. On a single day you cannot cook biryani as the Bagros biryani or Ambur biryani or any biryani. You can cook, but you cannot cook like them. Can you cook at the single attempt? I am challenging you. I am challenging each and everybody. Can you cook the same amount of quality or taste given by them? No, it is a skill. They have developed a skill. Skill will not come in a single day. What you are thinking is, in a single day I will get pass. Yes, in a single day you can get pass, but in a single day you cannot become a professional or professionalist. Understand that. Each and every one are professionalist. You need a habit of gaining knowledge. Professionalist is the person, he is having a habit of gaining knowledge. See, all the doctors will say that I am a practitioner. They will not say they are doctor. I am a medical practitioner. I practice medicine. I practice each and every day. I practice with each and every patient. Each and every day I practice engineering. Can you question yourself? Are you practicing engineering? It is a professional course. You have to practice. How many students are practicing engineering are going to get a better career? You will compete with them. You do not have to search at the end of the moment. See, interview is an end where your education ends and starting of your career. Interview is an end. When you are sitting there, your skills will help you, not your degree. Not whatever thing you have or in the paper will not help you. Not whatever you got as an experience will help you. Understand that. So why I am giving this much of moral words is, half of them are, if I am saying listen or not, half of them will listen. They know the advantage of gaining knowledge, but I am speaking for the rest of the person. At least improve your level of concentration. There are much and more training. According to the teacher, the training differs. How to increase the concentration level? According to teacher or according to their basic values, it depends. But the final thing is increase the level. Okay. So try to concentrate in this problem. At least you will get 16 or 20 marks. Okay. So how to find ZE is, that is moment of inertia divided by Y. So you have to find moment of inertia, the I component. Okay. Why I have given I total is I suffix total. Why? Because this is a built up section. What do you mean by built up section is, you are having 3 number of conventional sections. This is a flange and you have 2 flanges and 1 web component. So you have 3 components. Okay. If you need to find moment of inertia for 3 components, what is the formula for moment of inertia for a single section, that is a rectangle? What is the formula to find it? BD cube by 12, you know that. But if you are having 3 number of section, how to find that? For that you are having a formula, the individual moment of inertia. What is Ixx is individual moment of inertia. You know that formula, what is that? BD cube by 12 plus area into distance square. What do you mean by that is, you have to find the moment of inertia from a section. Either you can take reference axis as bottom or the center. You can find that. Okay. That is known as area into distance square. Okay. When you are finding for this problem, you can find Ixx as BD cube by 12. So what is the breadth of the flange? Flange breadth is how much? 140. What is the depth? 16. So breadth is 140, depth is 16, cube divided by 12. So how will you find area into distance square? 140 into 16. Okay. Now you multiply area into y square. What do you mean by y? From the bottom or from the reference axis. This is your neutral axis. So from the neutral axis, you can find the y distance, that is the individual centroid, where you will be having individual centroid of the flange. The total distance is how much? 200. If you subtract, this is 16 mm of depth, where you will be having the centroid at 8. So if you subtract 200 minus 8, you will be getting rest of the distance. Yes or no? This is the rest of the distance. So you will be having centroid from the axis as 192. Now your area into distance will be, are you getting this answer? Check it. See, you can find I total, that how many areas you are having. You have 2 number of flanges. No. Right now you know I for a single flange. For the bottom of the flange, will you be having same answer? Yes. Now you can find only for this web. This is Ixx for flange, not Iyy, Ixx for flange and Ixx for web. What do you mean by web is this vertical rectangle. So what is the depth of the vertical rectangle? No, total depth is 400. Only for this web section, remove the flanges. You have to remove 16 and 16. So what is the depth? 368. So if you are having a rectangle of depth 368 and what is the thickness? 8.9. So what is the formula for finding moment of inertia? BD cube by 12. What is the breadth here? Breadth is always x-axis. You add all the component. So why I have written 47786 into 2. Find I total. How will you find I total? I total is, you add all the component as 207.235 into 10 power 6. If you multiply this into 2, you will be getting 95573. Now if you multiply this component 82.57 into 10 power 6 into 2, 165.15 into 10 power 6. Are you getting that? Okay, why we are multiplying by 2? Because you have 2 flanges. You have 2 flanges, hence you are multiplying. Can you multiply 2 web? Are you having 2 web or single web? Single web. So that is why this value is, same value is taken here. So you will be getting 1.14 as shape factor. Okay. Now see, you are doing this much of work. What is the advantage or the use of this work is, you can calculate plastic moment. What is MP? MP is plastic moment. So what is plastic moment is, what is the formula? In the previous class I have given the formula. Fy into Zp. Now is Fy is given in this problem? Yes, it is given as what? 250. You multiply the 250 into, what is the value you got? Plastic moment as 1.16. You multiply 290 into 10 power 6. So you will be getting this answer, and finally in kilonewton meter you will be getting 290. Okay. Now another thing you can find, that is My. Ze into Fy. What is Ze? ZE is elastic section modulus. E is elastic, Z is section modulus. What is elastic section modulus? 1016177. You will be getting this answer. So when you multiply this, 252. So we have cut our section in x-axis for the previous case, and in this case we will be cutting in y-axis. So if you are dividing this I section into two halves, so you will be having another shape factor. So V equal to ZP minus ZE. So this concept you already know that this is the general formula. What do you mean by MP is plastic moment is Fy A1 Y1 bar plus F2 A2 Y2 bar. If I am cutting this section into two halves, if I have top and bottom only two parts, I can use A1 Y1 and A2 Y2. Okay, if I am cutting like this, if I am having three parts, that is two flanges and one web. If this is in the case, I can add A1 Y1, A2 Y2 plus A3 Y3. So you will be having three number of factors. Okay, if you are simplifying that, finally you will be getting a total area, that is A1 Y1 bar, A2 Y2 bar and A3 Y3 bar, like that, so that you are finding the three components. Okay. Now first to find ZP. How to find ZP is, you know the formula will change, A2 X2 instead of Y1 here. Hence if we are getting the section in Y axis, you will be getting X distance. So the total distance is 140 as the flange, and half of that will be 70. So for finding ZP, you have to find the centroid. Since you know that this is the half of the section, that is 70, the centroid will exactly act at 35 mm. You know that x1 bar is 35 mm. That you will be having bottom flange which is having 140 into 60. The centroid will act at 35. So this is the second centroid. Okay, now when coming to the third centroid, that is the web portion. So totally what is the thickness of the web, which is 8.9. When you are cutting this into two halves, it will become 4.45. 8.9 half is how much? 4.45, and within this 4.45 you will be getting the centroid. So it will be half of 4.45, that is 2.225. So this is your ZP, and when you are multiplying these components, you will be getting ZP equal to 164087. So you can check it. Now you have to find I total. We have found out ZP, and when you are finding ZE, you need the formula, that is I by Y. So what do you mean by I by Y is, I is moment of inertia, that is total moment of inertia. How to find the total moment of inertia? You have formula as IYY plus area into distance square. You know IYY, what is the formula? dBq by 12. For the previous case, if you are cutting into like this section, see, if you are cutting in the x direction, you will be taking IXX, and IXX will be what? BD by 12. When you are cutting in y direction, you will be getting the opposite, that is dBq by 12. So this will be your formula, and hence you will be getting IYY as dBq by 12. Now what is your depth of the flange, which is 16, and what is the width of the flange, which is 140. So depth is 16 and breadth is 140, cube divided by 12. You will be getting 3.66 into 10 power 6 as the answer. Okay. Now if you want to find area into distance square, your total area is 140. We are considering only this flange. So your total is 140 into 16, which will be the area, and the centroid will act at 70 mm. Since this is 140 mm, at the exactly the half of the distance you will be getting 70 mm. So you will be getting 70 minus 70. Totally it will be 0 mm. Power 4. Okay. When you are finding IYY, this is suffix W. IYYF. What do you mean by F is known as flange? IYYW is known as web. Okay. Now you are finding the moment of inertia for this web portion. Now what is your breadth for this web? Your breadth is 8.9. You know that this is 8.9. And what will be the depth? 400 minus 16 minus 16. So you will be getting 368. Okay. You are getting 21.61. Now how to find I total? Add all the components. You have two web components. This is web number 1 and web number 2. What is the answer of the web? 3.66. So you have two number of webs. So you have to multiply 3.66 into 2. You will be getting 7.32. Since we have two number of flanges, we are multiplying the moment of inertia into 2. You are having only one web component, and hence we are taking only one web component. You got 21.61 into 10 power 3. If you add this, 7.34. 7.34 into 10 power 6 divided by y. So what do you mean by y here is the distance. So what is the neutral axis distance? Total 140. Your neutral axis will be at 70. If you divide this component by 70, what is your answer? 104,855.6. This is mm power cube. So you can find V. So what is V? ZP by ZE. You can divide this two component. You will be getting 1.56. Now you can find plastic moment. How to find plastic moment? What is the formula? Fy into Zp. So your Fy is 250, Zp is 164087. If you multiply these two answers, you will be getting the plastic moment of 41.02 kilonewton meter. And how to find My? Zy into Fy, 26.21. Okay. Now you can understand that when you apply 26.21 kilonewton moment for this beam reaches the last elastic limit, and if it goes beyond 25.21 up to 41, it reaches the plastic stage. So beyond 41, this member is going to get broken after this stage. Now can you compare the previous answer and this answer? If I am placing the beam in one direction, I will be getting one moment. If I am placing the beam in another direction, I will be getting different moment. So if I am placing this beam like this manner, I will be getting high moment of resistance. The same beam, if I am placing in horizontal direction, I will be getting less moment of resistance. What was the answer you got? You check it for previous answer and this answer. What was the My there? My was 252. What is the My here? 26. You are getting nearly 10 times of reduction of moment. Yes or no? If you are providing the beam like I section like this, you are getting a resistance of 262. If you tilt the I section, and if the I section is provided in horizontal manner, it will be only resisting 26 kilonewton meter. Okay, what was the MP at x axis? MP 290, around 290 kilonewton meter you took the plastic resistance. Now when you are tilting this axis, how much it is taking? 41.02. Now can you find the difference? Instead of 2 feet by 1 feet, they are placing the beam like this. If they would have placed in another manner, the beam is going to deflect more and it is going to fail easily when the load reaches the limit. So this is the understanding by that. Okay. Now you can understand another concept. What is the advantage of having here is you divide 41 by 26. You divide these two answers. 41.02 divided by 26.21. What is your value? You got 1.56, and for the previous case, so what was the answer? If you divide those answers, 1.14. If you are dividing 290.25 divided by 252.5, you will be getting 1.41. Now, what is the difference you are finding here? Even though this section might be taking higher moment of resistance at x-axis, what is your understanding? The shape factor is how much? 1.14. But if you are twisting this beam, your shape factor is how much? 1.56. So it takes more plastic load before the collapse. So this is one of the another understanding. So you can find for whatever section is given to you. Okay, now you take down IS 800. Now you take down IS 800. You have annexure H. You can see in left hand side you have designation, and this column is designation. So what was your problem? So in this problem some certain section was given. ISMB 400. Okay, what was the shape factor value? 1.14. If you are referring the code book, so what was the answer here? At last they have given a column called shape factor, yes or no? They have given the same answer. Whenever these problems are asked like this, you can identify the section and you can get your answer. Final answer you can check it. Either whatever you are getting is right or not, you can check it by this annexure H. In this tabular column you have number of answers, you have section modulus ZE, plastic section modulus, that is ZP. So how to find section modulus? What is the formula? How to find shape factor? ZP by ZE. Both the answers are here. You can divide these two answers and get this. You should know to derive. See, I will say you what is the reason to derive. The answers are only given for the shop available sections, not the built up section. Whenever you are working as a civil engineer, in your site you will be not only using this component, you will be welding with another component. There will be design according to that. So when you are using composite section, you don't have in this code book. Here you should know to derive how a shape factor is being arrived, so that you can do it for multiple number of cases.